relatively simple project this weekend, which is basically making half a dozen of these brackets, which are apparently for mounting an engine in a Suzuki GSX750. I'm doing these for a friend down the local pool hall, and he wants two of these, and one each of these. So nothing terribly tricky, but it's one of those exercises where you've got to think about clamping it so that we can cut around these and get them out without fouling the edges at the breakout point. So I've redrawn these pretty much to scale, and it's going to look something like this. And because they need to be 4mm aluminium plate, I've acquired a bit of 6082 off eBay. I think it was about 20 quid. I could have got some 5060 grade, which is a little bit cheaper, but that's not rated for high temperature, and since these are engine mounts, I figured we'll go with a slightly better stuff. So what I'm going to do is crop that down into 85 90mm strips. I can get 4 out of these, and I'm figuring this will give me enough clamping points to be able to come in on the CNC and basically chop these out without too much difficulty. And going to get 3 of these strips, 4 on one, 2 on the other, which will leave me with enough to do a second batch if necessary. So 1 or 2 minor issues, but we'll come on to that in a minute. So we'll start by chopping this out, which I'll do on the table saw. I'm not sure the table saw manufacturers intended it for use in aluminium, but it's got carbide teeth on the cutting disc, so I've never actually had a problem. I've put 10mm thick plate through it before. As long as you go fairly slowly, it doesn't seem to be an issue. So there's my 2 plates for cutting these brackets out of. And there's the offcut, which I will keep in one piece until I need it. I may not, so we'll see. But I'm told these 2 brackets might not be 100% accurate, so I've got enough room here to do them again if necessary. So that's what we're working from, but to get to that point, I've had to redraw the original sketches because I didn't get sent any CAD files for this. I only got this PDF, and although it's well dimensioned and done properly, it does mean I've got to redraw everything, and there is a slight issue with it because these circles are slightly larger than these. These are 8.5mm holes, these are 10.5, and that means I've got to pick up a tangent point to the external radiuses, and you don't know exactly where on the circles these points are going to lie, so you actually need a little bit of geometry to know how to make a start on this. Once you've got one, you can snap to the tangent of the other, but of course you don't know where that tangent point is without a bit of geometrical construction. So at risk of giving a maths lesson, I'll have a go at explaining how I did that. When I first looked at this problem, I kind of assumed that there would be a ready-made solution waiting for me somewhere in the pages of Euclid. Unfortunately, nowhere in his 13 books does there seem to be a proposition which deals with specifically this issue of finding a tangent between 2 differently sized circles. Fortunately, there was another ancient Greek mathematician a century or so after Euclid called Apollonius of Perga, and he did a lot of work on conic sections. He actually gave us the terms ellipse and parabola and so on, and his work was quite influential in Ptolemy's Almagest as well, but he also wrote a now lost book on tangents. And in this book he worked on a problem where there was a 3rd circle, and the idea was to find a 4th circle which was tangent to the 3 points on the 3 circles he had already drawn of different sizes and different positions. That book doesn't exist anymore, sadly, but his works were preserved in the collections of Pappus, and you can still buy that in English. There is an English translation. I think it's 8 volumes and about 100 quid per volume, so sadly I don't have that in my book collection at the moment, but nevertheless the information of how you can solve this problem has been handed down through the generations. And the starting point, you've got 2 circles of uneven size. This is our 8.5mm circle and our 10.5mm circle, and you draw a 3rd circle which is the difference of the 2, so this is 2mm, and you simply join the 2 centre points together and find the midpoint of that line. You then need to draw another circle, which is the diameter of that line you've just drawn, and it's centred about that centre point. Most software will let you draw a circle from either the centre to the circumference, or possibly even from either side of the circumference. Failing that, you probably know the x and y offsets, and Pythagoras' theorem will tell you what the length of this circumference needs to be. So that's a fairly easy construction. But having done this, by joining the centre of this circle to the crossing point of these two red circles, you get the tangent, which is actually parallel to the tangent we're after up here. So all we've got to do is map that line up to the circumference of one or other of the circle, and that gives us our two tangent points. And there's a couple of ways you can do this. One is to simply join the centre of that circle to the crossing point of the two red circles, extend the line up. This is obviously going to be perpendicular to the black line that we've already drawn, to our tangent, and where it crosses the green circle, that's our tangent point there. And a lot of software will let you take a starting point and then mate with a tangential point on another circle. So that's one way of doing it. If your software doesn't let you do that, then another way to do it is to extend this black line that we've already found, because it's the crossing point of the red circles, to the centre of this circle, extend it out, and then if we bisect this chord, which is easy to do, you just create a circle about these 2 points and make an arc, and you probably did this even in primary school, and then you draw a line up from the crossing point to the crossing point of 2 arcs, and then that's the perpendicular, which gives us our tangential point here. And likewise, you can do the same thing with the chord across this circle, and go from this point to make an arc, and from this point to make an arc, and again joining the dots, and we get the tangent point to that circle. So it's a fairly simple construction, and most software should allow you to do this. You don't need anything like AutoCAD. Something like Inkscape is perfectly adequate for doing this kind of work. But that's basically what I did, and I recreated everything on our original schematic here, picking up all the tangent points using this method, and everything seems to match. Now it's just a case of cutting them out, and we'll see if they actually fit the engine. Right, I'm going to start with this one on the end here, because it will be the easiest to swing a clamp in to keep it in position. So I've got my workpiece already clamped down and lined up. There are a couple of minor issues though. First of all, I've had to extend the outside cutting path here either side, because when you start to plunge in you can get a bit of a wiggle, and I don't want to be denting the edge of the workpiece. So I will come in off the side of the workpiece, spin round, and then come out, and that should just preserve the edges. The other issue I've got is I'm going to be pocketing out with a fairly small 5mm bit, which needs to go right the way through the workpiece. So I've obviously got a piece of scrap material underneath it so that I don't go through and damage the bed. But at the same time, the only 10.5mm bit I've got happens to be a standard drill. And because that's quite high, I've got to be able to move the spindle high enough up to be able to get the bit in. And this becomes a bit of a game, because there's only so much play, so much travel I've got on the spindle. So on the one hand, I need it to come down low enough to be able to go through it, but on the other hand, I need it to be able to go up high enough that I can actually get the bit in. But anyway, I've fiddled around with it and got that so that it's just about works. And to begin with, I'm going to take out the 3 holes over here, do them slightly smaller, pilot them with a 6, take them out 8.5, and then take the big one out 10. And then we'll just spin round, pocket that out, and if that works, we'll carry on and do the next. Well, that was squealing like a pig. Maybe I need a bit more clamp force on that. But it's drilled them out nice and neat, so we'll set this up now and start cutting out the profile. Well, that's the first two done. I've given them a bit of a brush with some wire wool and just deburred the edges. They've cut reasonably cleanly and they feel nice and smooth and pretty solid, and more importantly they seem to be a pretty good perfect match for the original template. So these two are the urgent ones because they're the ones that need checking to make sure they're correct, and the other four I'll chop out next, and we'll take these over and see if they fit. And here's our final piece of jumbo-sized Meccano. I'm told these two should fit, which I took over yesterday, and the only issue people have had with these, because I think they're readily available plans for retrofitting a slightly more powerful engine into the bike, but I'm assuming these are M8 and M10 bolts, and there's a 250 micron clearance around them at the moment. If that needs to be opened up, it's not a major problem, you could probably file it at a push. But having measured everything up, they're accurate to about 100 microns, which is fairly typical for a job of this nature on my CNC machine. I can do slightly better, but it takes an awful lot longer to set it up and you have to cut very slowly. And anyway, I think they're good enough for purpose, and I'll pass them on to their new owner.